The CNN is one of the best image classification tools that we currently have access to. And no, I'm not talking about the news channel. CNN stands for Convolutional Neural Network, which is a type of neural net that uses convolutions where you have two functions added to create an output function. Now, that might be a bit hard to understand just using math, so let's look a bit deeper into an example that I made. For my project, I I classified images in the Fashion MNIST dataset, which is made up of 70,000 images that are 28 by 28 pixels wide. Each of these images is one of 10 classes of clothing items, being things like bags, t-shirts, or pullovers. And over time, I was able to get this model to accurately classify all of these images. A CNN starts off with our input or image layer, and to get that, we need to first convert our image into a 2D array, and then that should result in some kind of 28 by 28 array, with each of the values being between 0 to 1, representing the pixel values intensity on the grayscale. Now that we have that, we can pass the input through a second filter array, which will allow us to detect certain features, or like edges, circles, or huge areas of contrast in the image. Convolution is what powers these filters, and we perform mathematical operation between these two layers and end up getting a final output value called a feature map. For more detail on how feature maps and convolution works as a whole, then maybe you can check out my article in the description below. In CNNs, convolutional layers are typically made up of multiple feature maps, resulting in a really deep array. Our eventual goal in a CNN is to end up with an array that's deeper than it is tall or wide. This can help us in a variety of ways, mainly by preventing overfitting and increasing computational speed. Not only will we be able to generalize the test data better, but we can also get rid of unnecessary detail that won't actually help us in the classification problem. We can reduce the image's size by using something called max pooling. And what that does is it takes the maximum value in these 2 by 2 or x by x chunks and translates that into the new output image. This can result in size reductions by a factor of x of the array size, and it helps us get through the entire process much faster. Now let's put everything together into one final system. We started off with the input image layer, which we converted into a 28 by 28 array. Then we passed it into a convolutional layer with a depth of 8. After that, I applied a max pooling layer to reduce the image's size, and then passed it through another convolutional layer, this time with a depth of 16. The final step was to pass it through another max pooling layer before flattening or vectorizing the image. This allowed us to treat it as the input for some fully connected layers, which will allow us to classify the image as one of 10 potential classes, being the clothing article or the item. After this, the only step left was to train the model, and I did so for about 30 epochs. So, how did it actually perform? Well, to be completely honest with you guys, I think that it could have done much better. We had about 79% accuracy on the test data, and it performed at sub 30% accuracies on things like t-shirts. So key areas of improvement include training the model for longer, because even though I trained it for 30 epochs, it was still reducing its validation loss, meaning that it could still be trained for longer. Additionally, I probably didn't need as many convolutional layers or even fully connected layers to effectively classify the images. Just by reducing these, I probably could have increased the efficiency of my model, maybe even preventing skewness in the data. With my model, all that I really did was classify tons of tiny grayscale images, and I even got subpar accuracies. However, CNNs can be used for a whole lot more, and adding on to that, we can get accuracies over 95% for even complex images. So, what are some modern or current applications that we can use them for today? With image classification and object detection being some of CNN's strong suits, we can use that to improve facial recognition technologies, sort of like how you might unlock your phone. Additionally, we can also use CNNs for applications like Siri or Google Translate that need to be able to process and understand speech patterns. We use CNNs here to aid in parsing the data, sentence modeling, and making predictions. Lastly, we can use them for drug discovery, because CNNs allow us to recognize patterns between certain molecular structures, and we can even compose new compounds that have the potential to cure massive diseases. Now, thank you for watching this video, and I hope that you all learned something new from this. My project link and my article links are in the description below, so feel free to check them out.